Okay, so I wanted to take a look at inverse normal distribution. In this case, we're actually looking to find the x value, the average mu, the mean mu, or the standard deviation, and these are typically excellence questions. So three types of situations that come up. We've got a situation where they've given us sigma, mu, and the probability, and we're looking to find what value of x we need. There's also situations where we're looking to find the mu, the mean, and sigma, where we're looking to find the standard deviation. So of the four variables that we always have with normal, standard deviation, mean, probability, and the x value, any combination of these to be able to find the information we're looking for. So looking at situation 1, we are going to use the inverse normal in our calculator, and we're going to put in the probability, the sigma, and the mean that's been given to us, and we're looking for x in this case. This method is going to be dependent on using our calculators correctly. So with the calculator, depending on what version you have, you might actually have the option to make it more straightforward for yourself. So if we go into inverse normal, you'll notice that most of the newer calculators have left, right, or central, and you can pick which of these you want to use for the different situations. And this tells you the direction of the tail that you're looking to find. So am I looking out towards the left, or am I looking out towards the right to find the information? So as examples here, in this case I'm looking left, so I would use left. And in the older calculators the default is to left, so you would use left regardless. If I had a situation like this, just sketch it in real quick, that's looking to the right, so for the newer calculators you could use right. For the older calculators you would have to figure out, for instance, if the probability of this was 0.2, probability of the other side would be 0.8, and you would use 0.8 and left on your calculator. So if you have a new calculator, you'd use right and 0.2. If you have an older calculator, you'd use left and 0.8, and then do a 1 minus to figure out what you're looking for over here. Because remember, the total probability under the curve is 1. In this case, if we've got our mean in the middle, this is one where you can use the central if you've got the new calculator. And this has to be centered, so what I'm saying is that, for instance, if I'm a distance of like 0.2 in that direction and negative 0.2 in this direction, I'm centered, it's symmetrical, so I'm looking for the central, say 80%. So this central would be a keyword to look for. And you can use this range in your calculator. It will just calculate the 80% centered about the mean, so 40% on either side. If you have an old calculator, you're going to again have to use the left. And if you think about this, looking at the information using the left, we would use, knowing that it's 0.8 on either side, that it's 0.4 here and 0.5 over there for the whole left bit. So you would calculate using 0.9, and then you would want to subtract off the 0.1, calculate again for this bit here, and find the difference between those two. So we'll see if I can come up with an example for that later. But yeah, most of you guys have the new calculator, so it shouldn't be an issue. In this case here, this is not central, so I just wanted to clarify that one. You'll notice that the shaded in region is not centered about the mean. It is in fact only to one side of it. So a couple of ways we could solve this problem, but we would probably be looking at using either right or left. And remember that half of the curve is 0.5. So if you used the left from that value, we could do, say for instance, if this was a 0.2 probability, you would use 0.7 and left, and then subtract off half from it, and then minus 0.5 off of that to get your probability, because you don't want this part here. If you wanted to use right, you could use 0.5, sorry, not 0.5. If I have, not erasing, if I've got 0.2 of it within this region, I know that this part over here would be 0.3, so I could use 0.3 to the right, and then again subtract off subtract that off of 0.5, and you would get the probability for just the little blue region that you want there. So you just have to think about it and bring some awareness to it, whether you're going to use left, right, central, or a combination of things and then have to subtract away from one or subtract away from a half. So don't forget about your symmetry or your complementary ideas. Taking a look at examples. The mean time for Sue's bike ride to work can be modeled by the normal distribution with a mean of 25 minutes, so that's my mean, and a standard deviation of 4, my standard deviation of 4 minutes. She's trying to plan out when to leave for work so that she is on time 80% of the time. That's my probability, 0.98. How many minutes before work should she leave home? So what are we looking for here? Which situation is this? This is actually how many minutes before she should leave home. That's looking for the x value. If we put in what we know, my mean here is 25, and I've got a standard deviation of 4 minutes to either side, so I know that this would be 29 and this would be 21, for instance. And I'm trying to figure out what time, where is it, somewhere in here, x, such that %98 of the time she's on time to work. So I know I'm looking for the smaller end of this, because if her bike ride takes longer, for instance this region out here, this is longer, then I would imagine she'd arrive late to work. So we're looking for this range here where maybe she'll arrive early, because normally it'll take her 25 minutes, but sometimes it takes her a little bit longer. So normally she'll arrive a little bit early or on time, and 98% of the time she will not be late. Okay, so we've got our mu is 25, our sigma is 4, and our probability is 9.8. So into our calculators we can put in the inverse window. Let's take a look how it looks. So in inverse, thinking about selecting whether I want to do the tail to the left or the tail to the right. For this diagram I am to the left, everything to the left of that line, so I'll use left. The area, that's the probability, so in this case the area is going to be 0.98 because I'm looking for 98% of the time. My standard deviation is 4, and my mean is 25. So we've got that in. I'm looking for everything to the left, 98% under that line. Again, the standard deviation of 4 and mean of 25. And this button here has now calculated x for me, which tells me that this line here is 33.21. So 33.21. So really maybe 33 minutes before work. She'd be alright leaving. Again, she'll get there early sometimes, but 98% of the time she'll be on time. So in this case, for inverse normal, we used left. We used 0.98 for the area, or the probability, because we're looking for that area under the curve is the probability. And my standard deviation was 4, and my mean was 25, and we got 33 minutes is equal to the x, and that's the time that she needs to leave before work to ensure that 98% of the time she's on time. Okay, taking a look at situation 2, slightly different approach to this one. These are situations where you're looking for either the mean or the standard deviation. So finding x is pretty straightforward, but using these ones we have to do a two-step process. So the first step is to use the inverse normal calculator with sigma of 1 and mu of 0, and the given probability that we have to get z. So if I go backwards here, I'm going to set my standard deviation to 1 and my mean to 0. And the reason I'm doing this is because this is a standardized normal curve. So if I do that, the value of x it gives me will actually be my z value. A donut machine can be set up to dispense dough automatically to set average per donut. The amount of dough is normally distributed with a standard deviation of 5. Okay, so sigma equals 5. What level should the dispenser be set at to ensure that 95%, so 0.95% of the donuts contain at least 180 grams? So that at least is 180 grams, that's the x value. And what level? That's the average, so it's set to put something on an average. That's the mean that we're looking for. So we don't know the mean. that's unknown to us. Our standard deviation is 5, and I want 95% containing at least. The language at least tells me that I need to be looking for things that are bigger than 180. So I'm guessing, because it's 95%, that's a lot of this, that it's going to be down here 180, and I'm looking for everything above that, and that's going to be 95% under that area. So again, at least everything from 180 up, so I know that's going to be below my mean because it's more than half of my probability. So first thing I'm going to do in my calculator is try and find my z value. So into the calculator, in this case, I'm looking with a right-sided tail. I'm on to the right that I'm looking at. So I'll select right. The next thing I'm going to do is enter my area, 0.95. And then my standard deviation, leave it at 1, and my mu at 0. So I'm going to ignore the information they've given to me at the start, and I'm going to use the standardized normal curve to try to figure out how far away from the mean this x is going to be. And when I press enter, that x is actually the same as my z value. So this here will tell me how many standard deviations I am away from the mean if I've used a normalized curve. So that's minus 1.644. So that tells me minus 1.644 that I am that many standard deviations away from the middle, and that's my z value using the standardized normal curve. So that was using the inverse normal, and I put in I put in the right, that I was looking at tail to the right, an area of 0.95, keep my standard deviation of 1 and my mean of 0 because I'm looking to use the standardized one, and that gave me 1.644, and the negative tells me that I'm down to the left of the mean, I'm below it. So this tells me again how many standard deviations I am away from the middle. So my next step is going to be to use the formula. Z is equal to x minus mu over sigma, and the one I'm looking for is actually mu, so I need to rearrange this formula. First thing I'll do is times sigma to the other side, so sigma z is equal to x minus mu, and then I might subtract mu over here and take the sigma z to the other side. So there's my rearrangement for it. If you struggle with algebra, you can memorize that aspect of it. So the mu that I'm looking for is going to be that x value that I've been given. Now I'm actually going to use my values, so I'll use these ones. My x value is 180 minus 5 times negative 1.644. And when I put this into my calculator, I'm going to get, let's see, menu 1, I get 180 minus 5 times negative 1.644. Really important to watch out for those negative signs because they'll make a really big difference to your answer. So 188.22 is my actual mean. So maybe I should round that and say let's set it to 188 grams, assuming that they're using whole numbers here. So again, if we set the dispenser to 188 grams, that's the mu. We'd expect that 95% of the time I get at least 180 grams of dough. Okay. Second part of situation 2 here, the sprinkles dispenser from the donut machine is set to give 10 grams of sprinkles on average. So that's my mu. If 80% of the time, probability, the donuts receive more than 9 grams of sprinkles, what is the standard deviation? Okay, so here I want the standard deviation. Let's get a picture of what we know. 10, 9 is somewhere below that, and we're saying that 80% is more than 9. And I want to find my standard deviation. So same idea, I'm going to use the inverse normal. I'm going to use my right side, probability of 0.8, sigma of 1, mean of 0, using the standard normal curve. And here we go. Inverse, looking to the right, this time it's 0.8. My mean, my z value that I get here is again a negative, watch for those signs, negative 0.816, negative 0.8416, and that's going to be equal to my z, how far away, how many standard deviations away from the mean I am. So now to figure that out, I'm going to go back to my formula here, x minus mu over sigma, and this time I'm looking to find sigma, so I'll rearrange for that, timesing it to the other side, and dividing by z, using the information I've been given. So my x is 9, my mean is 10, and my z value is a negative 0.8416. Putting this one into my calculator, 9 minus 10 divided by negative 0.8, oh I need brackets, 9 minus 10 is negative 1 divided by negative 0.8416, and I get a standard deviation of 1.188 grams, and that's my standard deviation, in this case my mu. So again, if you're looking to find mu or sigma, the first thing that you have to do is find the z value that will tell you how far away from the mean that x value is that you're looking for. And to do that, we use a standardized curve, so we're going to set sigma to 1 and our mean to 0 and use the probability. That will give you a z value for how far away you are in terms of standard deviations. And then we use the formula z is equal to x minus mu over sigma, rearrange to find the particular value that you're looking for. So these are the inverse normal problems. Again, they're usually excellence only. Give a go at some of them. You can check in 1703 in the textbook, and ask me if you've got more questions.